Hey, it's Professor Davis. Here's your topics checklist from Module 8. Now, in this module, we're finishing up Chapter 4, and many consider this module to be somewhat of the heart of college algebra because it goes into the theory of what polynomial functions are all about. So let's take a look and see what sections are involved in this module. First, in Section 4.4, that's on several things: synthetic division, the remainder theorem, and the factor theorem. So I guess a couple of things we want to make sure we get down here. First, synthetic division. That is a way we can take a function that's a higher order polynomial function and divide it by a linear function. Notice we wrote here in the first bullet item, we wrote that linear function in the form x minus c. In other words, the independent variable x minus some constant. And what we can do with synthetic division is to take a higher order polynomial and divide it by that linear factor and do it easily without the long process of using long division on polynomials. So you want to take a look at example 2 to see how that's done. The main goal is to be able to rewrite a higher order polynomial function f of x in the form a linear factor x minus c plus some quotient, which will be another lower order polynomial q of x plus some remainder. And so we want to take a look at example 2 to see how that's done. And then a couple other theorems that are involved in this section. First, the remainder theorem. That's an easy way to determine what the remainder is when we divide a higher order polynomial function by a linear factor x minus c. We simply evaluate the function at f of c, and that'll give us our remainder. That's shown in example 3. And let me also mention the factor theorem here. That's simply put, the factor theorem tells us that if c is a 0 of a polynomial function, then x minus c must be a linear factor of that function. And that's shown in example number 6. And also we wanted to make sure we take a look at example 5 on the finding the remaining zeros for a polynomial function. So that's an example 5. So in section 4.4, we want to do problems 1 through 33 odd. Those start on page 199 in your summary notebook. And if you're probably using the ebook for that, that would be ebook screen 4.4-25. And then moving on to section 4.5. This expounds on what we talked about in section 4.4 with using synthetic division as a tool. This is on zeros of polynomial functions and the fundamental theorem of algebra. First, in this section, we want to be able to list the possible rational zeros of a polynomial function. That uses what's called the rational zeros theorem. That's where we take the factors of the constant divided by the factors of the leading coefficient and write all the different possibilities for rational zeros. And so what that allows us to do is to determine a list and kind of differentiate between the rational zeros and what might be irrational as a zero. So we also want to determine the real and complex solutions of a polynomial function using examples 2 through 4. Those illustrate that. And you'll also see a math cast on that at the class website. So make sure you take a look over that too. That uses a combination of graphing and synthetic division. So we want to go through exercises 1 through 17 odd in section 4.5, and then exercises 22 through 26. Those start on page 208 in your summary notebook, ebook screen 4.5-26. And then to finish off chapter 4, there is we kind of switch gears a little bit and we talk about functions that are made up of the ratio of two polynomial functions. Those are called rational functions. Rational like ratio, like a fraction. So given a rational function, here's what we want to be able to do. First, identify the vertical and horizontal asymptotes. So make sure you look over the rules on doing that, and that helps us write the domain and range of a rational function. So I usually find it best to find the vertical and horizontal asymptotes first, and then that will help us determine the domain and the range. They kind of go hand in hand. And then we want to be able to find the coordinates of the x and y intercepts. Finding the y-intercept is easy. We simply evaluate f of 0. To find the x-intercepts for a rational function, we want to find the values that make the numerator of the rational function equal to 0, but keep the denominator of the rational function non-zero. And then we want to identify removable discontinuities. These are values in a rational function that make both the numerator and denominator 0. And the result graphically is a hole in the graph. So we want to be able to also, to back that up, we want to be able to graph a rational function on your calculator. So see example 7 to see how that's done. And so to wind up the homework for this module, we want to look on summary notebook page 222, ebook screen 4.6-41. Notice that there's a lot of screens in this section. In section 4.6, we want to do exercises 1 through 15 odd, 33 through 37 odd. So make sure you take a look at all the rules there for rational functions. A lot of these have properties that you might not expect. Rational functions are very valuable to us. And so that is your topics checklist for Module 8.